Alright, so this is going to be the last component of the chemical bondings notes. This is part 5. If you haven't checked out parts 1, 2, 3, and 4, please do that first. That requires some knowledge. This video requires some knowledge from those other videos, so make sure you've checked those out. So when we look at chemical reactions, we get this chemical equation. And the chemical equation consists of some materials that we start with. These are called our reactants. In this specific reaction, there's C6H12O6, or sugar, and O2, which is oxygen, gas. And then that yields, we give this arrow, it's called a yield sign. And it's kind of like, in mathematics, you might think of it as an equal sign. So these reactants join together to yield some new things that come out afterwards, which are called products. So the reactants yield the products. In this case, this specific equation, I would say that C6H12O6 plus 6O2 yields 6 molecules of CO2 and 6 molecules of water. Every once in a while, you'll see energy listed on one side or the other. In this case, the energy is on the product side, meaning that there was energy already stored in the bonds of the reactants, and during this chemical reaction, that energy was released from those bonds. So it would you'd feel it as thermal energy when this chemical reaction happens. So it's kind of important that we consider some things that we talked about earlier in the year: the law of conservation of energy, law of conservation of mass. Law of conservation of energy says that energy can't be created or destroyed; it can only change forms. Law of conservation of mass says that mass cannot be created or destroyed; it can only change forms. And with that in mind, we need to keep chemical equations balanced. So really, what this means is that the energy that I have before the reaction, I must also have after the reaction. It can be in a new form, and really, typically, we're talking about a conversion either from chemical energy to thermal energy, or from thermal energy to chemical energy. And that's the endo-exothermic issue. If it's exothermic, you're taking chemical energy and converting it to thermal energy. If it's endothermic, you're taking thermal energy from the environment, from the surrounding area, and pulling that in and storing it as chemical energy within the new substance that's created. Law of conservation of mass, the way that applies is really talking about the mass of all of my reactants must stay exactly the same as the mass of all of my products. This is because every single atom that you started out with in your reactants, you still have in your products. They may have separated from each other and joined together in new ways to create new substances, but the atoms are still the same. You still have the same exact number of atoms. So I'm looking at this equation. I still have the same number of carbon atoms and the same number of hydrogen atoms and the same number of oxygen atoms on my products as I had originally on my reactants. That's what we mean when we say an equation is balanced. This equation, with coefficients and all, tells me exactly how many atoms I had of each element on my reactant side. And I must have that exact same number on the product side in order to have a balanced equation, in order for this equation to happen in the real world. If I, instead of having a 6 as my coefficient here, if I had a 2, then this reaction would not be true. It wouldn't be a true fact. It would be inaccurate, because I would not have the same number of reactants as I had products, and that would be an issue. And again, we're talking about the number of atoms of each element when I say number of reactants and number of products. You could have a different number of different substances, but the number of atoms are what's ultimately important. So we need to be able to balance chemical equations, and that's really kind of an important skill for us to have. And so when we do this, we kind of have multiple steps that we need to follow, and you can pick up a sheet or make your own of a grid that looks like this. We're going to call this our element inventory sheet. And the very first thing we want to do is take whatever chemical equation that we're trying to balance and write that in the top. And so I write that in this top section there. And then my next step is I want to put a box around my chemical formulas. And this tells me that, A, I cannot change anything that's inside of this red box. So this formula, KClO3, I can't just change it to KClO2. That's a no-no. This formula, this is the substance I have, I need to keep that specific formula. And then I can add coefficients though, I can change coefficients. So right now, if there's no coefficients written, we always assume that that's going to be a 1. So I can change this to a 2, though, or I can change it to a 4 or a 10 as I need to balance my equation. And then any coefficient that I list here changes everything in this box, but only what's in this box. So changing a coefficient here changes what's in this box, but not what's in this box. So it changes everything up to a plus or up to an arrow when we add coefficients. So my next step is just to list what elements I have. So I have K, which is potassium, I have Cl, which is chlorine, and I have O, which is oxygen. And then I count up how many of those elements I have in the reactant side, and then how many of those elements I have in the product side. So right now I have 1 K, I have 1 Cl, and I have 3 oxygen atoms. And on my product side I have 1 K, I have 1 Cl, and I have 2 oxygen atoms. Alright, so this is kind of cool. This one looks like it's going to be pretty easy because I'm already balanced here and I'm already balanced there. So all I need to do is figure out how to get just one more oxygen. But that's not really possible because this is the only atom on my product side, which is the right-hand side of the arrow, or the right-hand side of the equation, or after the arrow. On my product side, the only molecule I have that contains oxygen is this O2. And if I put a 2 coefficient here, that's not going to give me 3 oxygens, it's going to give me 4 oxygens. Because 2, my coefficient, times 2, my subscript, is 4. So now I'm still not balanced. Now, I'm going to make note of the fact that I can never get these numbers lower. As I said, I can never change this formula, so I never worry about trying to decrease the numbers in my grid. I always worry about just trying to make them increase until they're the same. Now, the next kind of step here is going, okay, well, my product, now I have more on my product side than I have on my reactant side, so I need to increase this. Try to get it up to 4. I can't get this up to 4 because if I put a coefficient, if I increase my coefficient from 1, which is blank, to a 2, that's going to cause me to have 6 oxygens. So I just want to get as close to 4 as possible without being less. And that's going to require me to put a coefficient of 2 here. But, oh man, now things look like they're getting more tough because this changes my Ks, it changes my Cls, and it changes my Os, not just my Os. Well, we just kind of got to roll with it here. So I've got 2 KLs now. I've got 2 CLs now. I'm sorry, 2 Ks, 2 Cls, and 6 oxygens. All right, well, I just take my next step. I go back to my product side. And now I'm going to look at trying to get my Ks balanced. It doesn't matter what you pick out. I just personally, I always work from the top down with only a little exception to that. So I'm just going to kind of follow my normal method of working with top down. So I want to get my Ks up to 2. Well, this is convenient. If I put a 2 here, that's going to change my K and my Cl. So they're both going to become 2 now, because 2 times my little invisible 1 is 2, and then 2 times my little invisible 1 is 2. So that's why I got that. Now I just need to get my O up. Now I have 2 on my molecule. I have 2 of that molecule, but that's not working out. So I'm going to cross this out. And I will need to get to 6. So 2 here times what is going to give me 6? Oh, that's going to be 3. So I need to change this coefficient to a 3. Now I've got 6 oxygen atoms because 3 times 2 is 6. So 2 and 2, that's balanced. 2 and 2, that's balanced. 6 and 6, that's balanced. So I need to now go back and check my work. So notice I can only change coefficients. So you can balance equations by only changing coefficients and only coefficients. After you think you have it balanced, go back one more time and just recount everything to make sure you didn't make an error. So 2 times 1 is 2, good. 2 times 1 is 2, good. 2 times 3 is 6, that's good. 2 times 1 is 2, 2 times 1 is 2, 3 times 2 is 6, so I'm good. So this is balanced. Now every once in a while, something's going to happen. For some reason, you're going to, actually let's clear the whole screen and kind of start fresh. Something's going to happen where you're going to end up, whether it's just because you picked something that you happen to pick the quote unquote wrong molecule to add a coefficient to, or you made a calculation error, whatever the case may be. you're eventually going to end up with something like this. All right, I've got K, I've got CL, I've got O. I do my quick counts: 1, 1, 3, 1, 1, 2. Oh, I need to get my oxygen up on this side, so I'm going to put another coefficient here. Let's put a 4 here. Let's just give that a shot. That's going to change my oxygen to 8. Oh, I'm still not balanced, so I come back to this side. I go, oh, I need to get this up as close to 8 as possible. Let's try a 4 here. All right, so 4. That's going to change my K, my CL, and my O. And I've got 4, 4, and 12. All right, that's awesome. Oh, this isn't balanced anymore, so I got to put a 4 here. That's going to change my K and my CL. So I've got 4. I've got 4. My oxygen still isn't quite right. I need to get up to 12. So I'm going to cross this out. 2 times what is equal to 12? Well, that's going to be 6. 6 times 2 is 12. And now I'm balanced. So I'm still balanced, but if you notice 4, 4, and 6, my coefficients, they're all divisible by 2. So I need to simplify this. Just like any math equation or math answer, you need to simplify. So in this case, I would go back and I'd say, okay, if I divide 4 by 2, I get 2. If I divide 4 by 2, I get 2. If I divide 6 by 2, I get 3. And that's my simplified answer, because 2, 2, and 3 do not have something that they're all commonly divisible by other than 1. So this is basic simplification of your chemical formula or a chemical equation. You ultimately need to do this when you do your calculations. So that's how we balance chemical equations. Make sure you get lots of practice with this, and if you have questions, stop in and see me. But this, more than anything else, is just something that requires practice. Some of them are really easy and you'll get done in seconds. Other ones are more difficult and might take 5 or 10 minutes just at hacking away at a problem to ultimately get it done. But if you just follow the steps, the back and forth steps, pick an element, try and get that element balanced or as close as possible. Then pick the next element, try and get it as balanced as close as possible. As long as you do that and you're careful, make sure you do your counts right, make sure that you do your multiplication right, you will always ultimately have success. It just might take more time than you would hope for. So if you have questions about it, make sure you stop in and see me or email me to get some clarification. Thanks, guys.